Given this rational expression, divide to find the quotient and the remainder. And in this video, we're going to demonstrate polynomial long division. As a reminder, the expression in the numerator is called the dividend, the expression in the denominator is called the divisor, and in long division, the dividend is the quantity that goes underneath the division box. The divisor is located out here, and the quotient is going to be indicated up here in the top, and the remainder will be what's left down below. So let's begin by putting the dividend underneath that division box. We have 2x cubed minus 5x squared. We're missing an x to the first power term, so let's leave a little bit of space here before we add the 3 at the end. Then we'll put our divisor, x minus 2, out here, and now we're ready to begin dividing. This process is very similar to long division with real numbers, with only a few minor differences. To begin with, we're going to compare the first term of the divisor to the first term of the dividend. But instead of asking ourselves, how many times does x go into 2x cubed, I find it easier to think about this as x times what is going to give us 2x cubed? Well, x times 2x squared is 2x cubed, and so that is going to be the first term of our quotient. And now, just like with real numbers, we're going to multiply 2x squared times the divisor. But in polynomials, we want to make sure that we're multiplying that 2x squared by the entire divisor, which means that we'll have to distribute 2x squared into each term. So we start with 2x squared times x, which is 2x cubed. Let's note that this first product matches the term that's directly above it. Then we'll take 2x squared times negative 2. 2x squared times negative 2 is negative 4x squared. And now, similar to the process for real numbers, we're going to subtract this from the original dividend. To subtract a polynomial from another polynomial, the process is to distribute a negative into that polynomial and then combine like terms. And once we distribute that negative, it's going to cause all these signs to switch. In order to make this step a little bit easier to remember, I actually like to use a little rhyme here where I draw the line and change the sign of each of the terms. I also like to circle the new sign, which helps me keep track of what the new sign is. So changing the sign is the same as distributing the negative, which is enabling me to subtract our polynomial from the original dividend. So now we combine like terms, and notice this first term is going to drop out. With every iteration of the polynomial long division, this first term is going to drop out. And then we move on down the line, we see negative 5x squared. Now this is a positive 4x squared, so we're going to be adding 4x squared to that to get minus x squared. There is no x to the first power term, so we'll just again leave a little bit of space there and bring down that 3. Essentially, we can think about this as combining 3 with 0 to get 3. And then we repeat the process, taking the divisor x minus 2 and now dividing it into this new dividend. So just like before, we're going to compare the first term of the divisor to the first term of this new dividend and say x times what is negative x squared. X times negative x is negative x squared, so negative x is the next term of our quotient. And now again, it's time to multiply our negative x times the entire divisor, which means that we'll need to distribute it in to both terms. We'll start, first of all, negative x times x is negative x squared. Remember, with every iteration, this first product should exactly match the term that's above it. And then from there, we have negative x times negative 2, which is positive 2x. Now, we're going to slide positive 2x into this empty space region here, just as a visual reminder that there is no x term in that new dividend that we'll be able to combine this with. And again, we're at the subtraction step. Remember, to subtract polynomials, we're going to distribute a negative into the second one and then combine like terms. When we distribute that negative, the signs change. So the rhyme that we're going to move forward with is that we're going to draw the line and change the sign, circling the new sign. This is equivalent to distributing a negative into the second polynomial, which is how we subtract polynomials. Now we combine like terms. Notice again, this first term cancels out. Negative x squared plus x squared is just 0. Now we have a negative 2x, which is combined with nothing, which yields negative 2x. We also have positive 3 combined with nothing, so that combination is going to be positive 3. So let's consider the question, when would we stop this process? We would stop dividing when the degree of the remainder is less than the degree of the divisor. This is our remainder, and its degree is positive 1. The degree of the divisor is also positive 1, so right now the degrees are the same, which means that we need to cycle through the long division one more time. So we hit the repeat button again, and we're going to treat this remainder as the new dividend. We begin by looking at the first term of the divisor and comparing it to the first term of the new dividend. And then we ask, x times what is negative 2x? X times negative 2 is negative 2x, so negative 2 is the next term of our quotient. Now we multiply, and negative 2 needs to be multiplied by the entire divisor, which means that we distribute negative 2 into both terms. So negative 2 times x is negative 2x, and again you can see that this first product does exactly match the term that's above it. Then negative 2 times negative 2 is positive 4, and this is where we subtract. Remember, to subtract polynomials, we distribute a negative into the second one and combine like terms, and the rhyme that we're going to use to help us remember to do that is that we're going to draw the line, change the sign, and circle the new sign. This is what we would get when we distribute a negative into the second polynomial, and now it's time to combine like terms. Notice the first term drops out again, that should always happen, and positive 3 combined with negative 4 is negative 1. Now our remainder is a constant, and the degree of a constant value is 0. That means the degree of our remainder is now less than the degree of the divisor, which means that we're ready to stop with the long division. So it's time to clearly express the quotient and the remainder. The quotient is located up here, so it's 2x squared minus x minus 2, and our remainder is the negative 1 that's located down here, and so this is the answer to part A. In part B, we're being asked to rewrite the rational expression using the form quotient plus remainder over divisor. Let's notice that the original rational expression is something that we consider to be improper. A rational expression is improper if the degree of the top is bigger than the degree of the bottom. This is similar to what we've seen with numbers. An improper fraction is one where the numerator is bigger than the denominator. So we can rewrite this improper rational expression in this form by saying our quotient, which is 2x squared minus x minus 2, plus the remainder, which is negative 1, over the divisor, which is x minus 2. So this is our answer for part B, but let's notice that it's similar to what happens with improper fractions with real numbers. We can write an improper fraction in the form of quotient plus remainder over divisor, and that's what gets us from the improper fraction to the mixed number. So we can think about this in a similar way. We can get from the improper rational expression to something that feels like a mixed number version that's equivalent to what we started with.